Hey there everyone, I hope you're rocking today. We in geophysics rely on seismic data to help us understand the Earth using sound. This is pretty amazing in itself, but chances are if you are a geophysicist, your seismic data sucks. That means all your inversions suck, all your attribute analysis suck, all your predictions suck. You might be able to find nice horizons in your data, but fault, pinch-out, fracturing, attributes, nope. Well, sort of nope, and I'll be talking about it in this video. Before I get going, if you have any questions or any concerns or anything that you want me to talk about, leave them down below. Let's get rocking. Hi there, I'm Dr. Chris, a professional geoscientist, and your land seismic data sucks. I should say probably sucks because chances are you are working with sparse, old school land seismic data sets. Now, I won't say old data, that would be counterproductive. Don't use old data. I said old school land seismic. What do I mean by old school land seismic? Well, I mean it's sparsely acquired. It has large source separations, large receiver separations, large line separations, which has the property known as cheap, and in many camps, the secondary property known as good enough for the girls that I go out with. It's not good enough. The analogy is this. With today's technology, you can have a 4K TV where you see the spots on the spots on the spots of the actors' faces, or you can have a cathode ray tube TV. Chances are you are using the cathode ray TV of seismic data, and it gets worse. When I go to conferences and I watch talks with people and their pet equations, quite often it bores me to tears because A, they don't know how to give presentations. That's another video. And B, all they want to do is talk about the finer points of their equations, the derivations of their equations, the subscripts and the superscripts. Don't get me wrong, those are very important, but they are very boring. What I want to see is the results. It surprises me more and more when I go to these talks and they talk about getting results out of these equations. They speak of computation time, better computers, more tweaks to the algorithms, but it is almost never said, hey, you know what would be a better idea? If we had way better data. Dude, that's some crazy right there. Urba et al. 2015 has an amazing chart that should ring the death knell of crappy old school seismic land data. They show that increasing the density of seismic surveys unlocks the power of algorithms and tools to take advantage of the fine sampling and data redundancy. This opens the door properly to real attribute analysis, real inversions, and real insights into seismic data. But this can only be properly done on the 4K seismic data, not the cathode ray tube seismic data. Essentially, the better you sample the wave field, the more cool you can do. Yes, there are limitations in sampling the wave field properly. There's noise, earth filter, regulatory limitations, money, willpower. I'm sure there are more reasons why you can't sample the wave field properly, and I'm sure they are all quite salient points. But what it boils down to is your cathode ray tube seismic data is probably going to be missing the faults, the pinch-outs, missing the more correct inversions, missing thin beds, missing AVO, missing a whole load of stuff. There are at least 3 things that you need to do to make sure that you are able to get your 4K seismic data. Number 1, denser receivers. Technology has been advancing over the years. It's gone from cabled systems where guys had to drag cables through forests. Outside a university setting, I haven't even seen cable systems used. What I have seen and what is massively used now are wireless nodes and shrinking technology. A million node system is within reach, and you have just got to be thinking about it when you design your seismic surveys. Number 2, denser sources. Fiber size was developed for a reason. It's easier to use, it's safer, but of course there is not as much energy put into the ground. The solution to this is, of course, take a hell of a lot more vibe points compared to dynamite. Enter independent simultaneous sources, or the dozen other names that it goes by in various other companies. The elevator pitch of ISS is simply this: more vibes, shooting at the same time, better processing, better algorithms, way better data. Number 3, while this is not a technique, it will increase your possibilities of getting funding for some serious seismic data, and that is bring all the stakeholders together that will benefit from better seismic data. Better seismic data doesn't just mean better horizons for picking. What it means is better drilling, more accurate drilling, safer drilling. I am sure that the engineers would love to know what 4K seismic data can do for them. And those were my thoughts on, let's say, your insufficient seismic data. Sometimes you have no choice but to deal with the low resolution, and sometimes it's just willful ignorance or willful neglect. Tell me your thoughts. I'd like to talk to you. Thanks for watching. If you like this video, please give me a big thumbs up, subscribe to my channel, add me to your LinkedIn, or even better, share my videos through your networks. Till next time, I'm Dr. Chris. Keep rocking.